Okay. All right. So there are a couple of different ways to go about this. There are a couple of different ways to go about this. We could do long division. Long division always works. And we could simplify and use the simplified version. So let's do both for this one. Let's first review long division. Okay. 2 over 8 as a fraction. 2 over 8 as a fraction. You're solving 8 is the divisor and 2 is the dividend. All right. On the side here, I'm just going to put our multiples of 8. We have 8 times 1 is 8. 8 times 2 is 16. 8 times 3 is 24. 8 times 4 is 32. And 8 times 5 is 40. Okay. All right. So how many times does 8 go into 2?
Oh, I don't think that's possible.
Not possible. So 0. 0. 8 goes into 2 0 times. 0 times, okay? The long division process, we do 8 times 0, and we put that underneath 2, and we subtract. What's 2 minus 0?
2 minus 0, 2.
2. And then remember, we got to bring down a 0 every time we do that. And put our decimal spot. All right. Now, how many times does 8 go into 20? How many times does 8 go into 20? How many 8s can we fit into 20?
16. Well, 2 8s.
2 times. Yep. 2 times. 2 times. Because 16. 3 is too much because it goes to 64. So I'm going to put a 2 up here. All right. And then I'm going to do 8 times 2. 8 times 2 and put it underneath the 20. What is 8 times 2?
16.
16. All right. Now I subtract. What's 20 minus 16?
4.
4. 4. Okay. I create another imaginary 0 to bring down. How many times does 8 go into 40? How many 8s fit into 40?
5.
5. 5 times. 5 times. 8 times 5 is 40. 8 times 5 is 40. So when we do 40 minus 40, now we get 0. That's our sign that we're done. So 0.25. 0.25 is your answer.
Yeah, let's check this down first.
All right. Before you move on, let's review really quickly simplifying fractions. So 2 over 8. 2 over 8. I can divide these both by 2 because they're both even numbers. I can divide these both by 2. What's 2 divided by 2?
By 1. It's 1.
1. 1. And what's 8 divided by 2?
Oh, 2 times 4.
2 times 4 is 8. So 8 divided by 2 is 4. 2 times 4 is 8. So 8 divided by 2 is 4. Perfect, perfect, perfect. All right. So 2 over 8 is the same fraction as 1 over 4. 1 over 4. How are you with your change amounts? Do you know how much is in a quarter?
25.
25 cents. Do you know how to write 25 cents as a decimal?
Yeah.
How do you write it?
0.25.
0.25. Okay. Now look, right? The answer is 0.25. So 1/4, that's 1/4 because a quarter is $1 split into 4 pieces. So 1/4 is 0.25. That's another way that you can see it. All right, let's move on.
2 over 15 divided by 2 over 12.
All right. Do you know how to divide fractions? Do you know how to do it?
Divide fractions. I think I forgot.
All right. So let's review first. You keep the numerator the same. Keep the numerator the same. You change the division to multiplication. And then you flip the bottom fraction. Keep, change, flip. Mathematicians, we do not actually divide fractions. Nobody actually divides fractions. We turn them into multiplication. So we keep the top the same, keep the top as 2 over 15. We change the division to multiplication. And then we flip the bottom fraction. 2 over 12 becomes 12 over 2.
Mhm.
All right. Now, multiplying fractions is easy. You just multiply straight across. So for the numerator, we do 2 times 12. For the denominator, we do 15 times 2. What is 2 times 12?
24.
24. 24. And what is 15 times 2? 15 times 2. That might not be on your multiplication chart, but 15 times 2 is the same thing as 15 plus 15.
30.
30. 30. 24 over 30. 24 over 30. Now, we can simplify that fraction. What number can I divide both of these by? What number can I divide both of these by and get a whole number?
2.
I can divide by 2. All right, let's divide by 2. All right, what's 24 divided by 2?
4 divided by 2.
Mm-hmm.
12.
12. And then 30 divided by 2. You just did 15
15.
times 2 is 30. So, yep, 30 divided by 2 is 15. All right, we have 12 over 15. Can we simplify that? Is there a number that divides both 12 and 15?
Divide.
Yep. Is there a number that I can divide by 12 and 15 and get a whole number?
Two.
2 works for 12, but it doesn't work for 15.
Next.
6 works for 12, but it doesn't work for 15. Go back down to 3. Go back down to 3. All right. So what's 12 divided by 3? What's 12 divided by 3? 4. Perfect. What's 15 divided by 3?
15 divided by 2. 5.
5. 4 over 5. 4 over 5. What's next?
6 over 15 divided by 3 over 6.
Okay. I'm going to scroll out big enough so that you can see the top problem. If I use keep, change, flip on this, what problem am I doing instead of this division? What should I do for keep, change, flip?
Keep, change, flip.
Yep. Look at the example up here.
Okay, let me go back. You have to keep 6 over 15.
Uh-huh.
Change the dividing symbol to times.
Uh-huh.
And 6 over, change 3 over 6 to 6 over 3.
Perfect, 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 perfect. So my numerator is going to be 6 times 6, and my denominator is going to be 15 times 3. What is 6 times 6? What is 6 times 6?
36.
All right. And what is 15 times 3?
15 times 3. 45.
45. 45. Okay. Now I'm going to ask you the question again. Is there a number that divides 36 and 45 evenly? To answer this, what I want you to do is look in your times table and either look in the rows left to right or look in the columns up and down. Is there one row or column that has both 36 and 45 in it? Is there one that has 36 and 45 in it?
I think there might be 3, but 5 has both of them. But I'm trying to look at 3.
5 has 36, but it doesn't have 40. Excuse me. 5 has 45, but it doesn't have 36. Hold on one second. I'm gonna get us in. 3 does work. Okay. So I'm going to add the multiplication chart to our table, to our Zoom so that we have it here. All right. We're looking for one that has both 36 and 45 in it. 36 and 45. Which of these rectangles has 36 and 45 in it?
Let me check. 3 has 36.
3 has 36, but it doesn't have 45. Let's try and go bigger.
4 doesn't have 35. Not 5.
All right, keep going.
Not 6. 3. 9. Yes, 9.
9. Perfect. 9. Okay, 9. So 36 divided by 9 and 45 divided by 9. What's 36 divided by 9? What number times 4 times 9 equals 36?
36 times 9.
Or what's 36 divided by 9? 9 times what equals 36?
9 times 4.
9 times 4. So 36 divided by 9 is 4. All right. What about 45 divided by 9? What about 45 divided by 9?
9 times 5.
5. Perfect. 5. So 4 over 5 is our final answer. All right. Let's keep on going.
Okay, there's one that just says 10.
Huh?
There's a problem that just says 10.
What are your answer choices?
70 over 7, 68 over 7, 60 over 7, and 73 over 7.
Okay, so let's divide these. Okay, what's 70 divided by 7?
7 just divided by 7.
Uh-huh. What can I divide these both by?
10.
I can divide 70 by 10, but I can't divide 7 by 10. I can only divide 7 by 7.
7. Yeah, just 7.
Just 7. So let's divide both of them by 7. What's 70 divided by 7? 7 times 10. Yep. 7 times 10 makes 70. So 70 divided by 7 is 10. Yes, absolutely. All right. What's 7 divided by 7?
49.
That's 7 times 7. Go the other way. Divided by 7.
1 time.
1. 7 divided by 7 is 1. So 70 over 7 is equivalent to 10 over 1. It's equivalent to 10 over 1. So we didn't even have to try all the answers because the first answer was the right one.
Okay. Now this one says 1 over 6 of 12.
All right. 1 over 6 of 12. So 1/6 of 12. The word of in math means multiplication. Multiplication. So they're asking you to do 1/6 times 12. 1/6 times 12. And just to make it clear, I'm going to write 12 as a fraction, 12 over 1. 1/6 times 12 over 1.
They didn't mean use of. They could have just used the times thing.
I know. They get so silly in this math when they put these words, when they write up. We already know what the time symbol means. I don't know why they did that. But you know how, like, okay, if I'm talking to you in words, right? And I say, give me half of your toys, right? Give me half of your toys. Right? In English, when I say it out loud, I say, give me half of your toys. So I use the word of in English, but in math, I'm not going to say, give me 1/2 times your toys, right? That sounds weird. So the reason why they're showing you the word of is so that when you hear stuff, you know what math to do. Give me half of your toys, take your toys and multiply by 1/2. Give me 1/3 of your toys, take your number of toys and multiply by 1/3. So, yep. All right. 1/6 times 12 over 1. To multiply fractions, you just multiply straight across. So we're going to do 1 times 12 over 6 times 1. What's 1 times 12?
1 times 12.
And what is 6 times 1?
6.
All right. We need to simplify this fraction. What number can I divide 12 and 6 by?
2.
I can do 2. Can I do bigger than 2? I can do 3 too. Can I do bigger than 3?
Yeah, I think 6 is the only one.
6 is the biggest. So let's pick the biggest number. So we don't have to do this twice. All right, let's pick the biggest number so we don't have to do this twice. What is 12 divided by 6?
12 divided by 6. 2.
Perfect. And what's 6 divided by 6?
1.
1. 2 over 1. 2 over 1, which is just 2. 2 is your answer. So 1/6 of 12 is 2. If you have 12 pies and I tell you, give me 1/6 of your pies, you're going to give me 2 of your pies. 1/6 of 12 is 2.
Another question says 6 over 18 divided by 3 over 8.
All right. What's the trick for that? All right. You are dividing fractions. We do not divide fractions. Say that out loud. We do not divide fractions.
We do not divide fractions.
We multiply by the flip.
Multiply by the flip.
Yeah, keep, change, flip. We do not divide fractions. We kick flip. Keep, change, flip, kick flip. You do any skateboarding?
Nope, but I heard skateboarding.
All right. So in skateboarding, they have a move called the kick flip. Okay.
Yeah.
So we don't divide fractions. We kick flip. We do keep, change, flip. Okay. You can also think of it as we don't divide fractions. We go to, KFC, the restaurant KFC.
Yeah.
KFC, even though it switches the F and the C, it still is memorable, right? Keep KFC, Kentucky Fried Chicken, Kentucky Chicken Fried is keep, change, flip. So either think of it one of two ways. We either go skateboarding or we're going to go get us some chicken. But we do not divide fractions. All right. So 6 over 18 stays the same. Change the division to multiplication. And when I flip, what am I going to get when I flip?
The division symbol into a multiplication symbol.
Yep, I did that.
And then 3 over 8 and 2, 8 over 3.
8 over 3. 8 over 3. All right, we're just going to multiply straight across. We're going to multiply straight across. What is 6 times 8? You can use your multiplication chart for that. What's 6 times 8?
48.
48. All right, and then 18 times 3. 18 times 3.
54.
54. 54. Okay. Is there a times table that has 48 and 54 in it? 48 and 54.
48 and 54.
Yep.
Times table has 48 and 54. Oh,
Yep. We got,
no.
but look in the chart. Look in the chart. Find a 48. Okay. I'm looking, find a 48 first. All right. I see a first 48 here with the 4s, but it stops right there. So I got to go bigger. All right. Let's find my next 48. Okay. My next 48 is here in the 6s. Let's look for 54. Oh, it's actually the next number.
Oh, wow.
So 48 and 54 both divide evenly by 6. So let's divide by 6. 48 divided by 6 and 54 divided by 6. Since we just looked at the multiplication table, right, we know that 6 times 8 is 48. So 48 divided by 6 is 8. 6 times 9 is 54. So 54 divided by 6 is 9. Cool stuff?
Mm-hmm.
So 48 over 54 becomes 8 over 9. 48 divided by 54 becomes 8 over 9.
Okay, it says 2 over 5 and 7 at the side.
All right. That is 7 and 2/5. 7 and 2/5. 7 is the whole part and 2/5 is the fraction part. This is called a mixed number. This is called a mixed number because you have the whole part and the fractional part, 2 mixes. So you have seen this before. You have seen this before where we turned a mixed number into an improper fraction. I don't know if you remember it, so let's review it. Let's review it. All right. First, we need to turn 7 into a fraction. First, we need to turn 7 into a fraction. But we need the fraction to have a common denominator with 5.
Mm-hmm.
Okay, so I'm going to take 7, turn it into a fraction, and multiply that by 5 over 5, right? 5 over 5 is just 1. I'm not actually changing the value of the number. I'm just making it in fraction form different. What is 7 times 5?
Yeah. Let me check. 35.
35. And what's 1 times 5?
1 times 5. 5.
All right. So 7 and 2/5. Because 7 is 35 over 5, 7 and 2/5 is 35 over 5 plus 2 over 5. Okay, 35 over 5 plus 2 over 5. When you are adding fractions, you only add the numerators. You leave the denominator alone. So leave the denominator as 5. What is 35 plus 2 for my numerator?
37.
37. 37 over 5 is equivalent to 7 and 2/5. 37 over 5 is equivalent to 7 and 2/5.
3 over 4 and 6 is on the side.
All right. 6 and 3/4. 6 and 3/4. We're going to do the same thing. We're going to turn 6 into a fraction with 4 as a denominator, and then we're going to add those 2 fractions. All right. 6 over 1. 6 over 1 times what over what? What do we want the denominator to be?
The same.
Yep. So what do we want it to be?
The fourth.
4. So we're going to multiply by 4 over 4. 4 over 4. What is 6 times 4?
24.
24. And what's 1 times 4?
4.
4. Okay, so 6 equals 24 over 4. 6 equals 24 over 4. So now this problem becomes 24 over 4 plus 3 over 4. All right, when you're adding fractions, you leave the denominator alone and you only add the numerators. So what's 24 plus 3?
37.
You got it. 27 over 4.
The last problem says 1 over 11 of 66. 1 over 11 times 66.
Oh, excuse me. 1 over 11 times 66?
Yeah.
All right, so let's turn 66 into a fraction. 1 over 11 times 66 over 1. 1 over 11 times 66 over 1. All right. When you're multiplying, you multiply both the numerators and the denominators straight across. When you're adding, you leave the denominator alone. So what's 1 times 66?
66.
Perfect. What's 11 times 1?
Okay, what did you say?
11 times 1.
11.
All right. Now, what number divides both 11 and 66? Let's look at our times tables. Which column has both an 11 and a 66 in it? First, look for 11. All right. And then see where you see 11, go find the 66.
So 11 times 1.
11 times 1. Yep.
And 11 times 6.
And 11 times 6. Absolutely. So 66 divided by 11 is 6. And 11 divided by 11 is 1. So 1 over 11 times 66 over 1 is just 6 over 1, or 6.
Okay.
Cool stuff.
Yep. Yes.
All right. I want you to get better at knowing your times tables.
Yeah, I need to.
Okay. The way to practice that is not to sit at that paper and stare at it forever trying to memorize. The way to practice that is to build it using things that your memory will already memorize. Okay. So I always like to go to music. You need to practice skip counting. Let me get a new whiteboard out. All right. Practice skip counting. So let's start with the twos. We're going to skip count up. By twos. So if you go up by 2, what's your next number?
4,
Up by 2.
6,
Up.
8,
Up.
10,
Up.
12,
Up.
14,
Up.
16.
All right. So now, when I am asking myself, what is 2 times 7? What is 2 times 7? Okay. I count by 2s until I get to 7. Use your hands while you're getting started. 2, 4, 6, 8, 10, 12, 14. Okay, when I get to 7 on my fingers, I'm at 14. So 2 times 7 is 14.
Mhm.
All right, let's skip count by threes. Let's go up by threes. 3, 6. Uh-huh.
9,
Keep going.
12,
Okay,
15,
let's go.
18,
All right.
21,
Uh-huh.
24.
All right. So now, if somebody asks me, what is 18 divided by 3? What is 18 divided by 3? Skip counting still works. Okay. I'm going to count up by threes until I get to 18. And then the number of fingers that I have up is the answer. Okay. 3, 6, 9, 12, 15, 18. I have 6 fingers up. So 18 divided by 3 is 6. Okay. Skip counting works for multiplication and division. You just one, you go forward, the other, you go backwards.
Mhm.
All right. Let's go up. Let's go challenge mode. Let's go up to our 7s. Let's go up to our 7s. What's 7 plus 7?
14,
All right. What's 14 plus 7?
21,
21 plus 7.
28,
28 plus 7.
35,
Plus 7.
42.
42. When you're adding 7, it might help to break it down, right? Do plus 5 plus 2 or plus 4 plus 3 or whatever you need. So 42 plus 7.
49.
49. Okay, 49. Okay. Use skip counting. I want you to answer the question. What is 28 divided by 7? Use skip counting. Count up until you get to 28. How many fingers do you have up?
4.
4. 28 divided by 7 is 4. Perfect. 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 All right. So, how you feeling? You want to do some division practice or you maxed out for the day?
I'm maxed out for the day.
All right. All right. I'm not mad at it. You gave a good, strong effort today. I even pushed you a little extra at the end there. I'm proud of you. That was a good session. Do you feel good?
Yeah.
All right. I feel good about it too.